This problem came in this year's electrical engineering gate. So the problem is on operational amplifier, and it is stated as follows. The op amps in the following circuit are ideal. The voltage gain of the circuit is dash, and the answer should be represented in the nearest integer form. And so this is a typical 2 op amp structure. So a cascade of op amps where the output of the first op amp, this is the output of the first op amp, which is fed to the inverting input terminal of the second op amp, and then the voltage that is applied to these two op amps is in differential form. And so if we regard this as V in, the positive polarity is applied to the plus terminal of the second op amp, and the negative polarity is applied to the plus terminal of the first op amp. So let's see how we can proceed with solving this problem. Now the first op amp structure, this op amp structure is that of an non-inverting amplifier. The input is applied to the plus input terminal, and we can see that this representation is that of a non-inverting amplifier. Note that what I have done is I have segregated V in the form of Vx minus of Vy. And so if we look at the output of the first op amp, let's name it as V0. Then V0 is simply equal to 1 plus feedback resistance of 10 kilo ohm divided by input resistance of 10 kilo ohm multiplied by this input voltage. And upon solving this, V0 turns out to be 2 times Vy. So the voltage applied here is twice that of the input voltage. Now, when we look at this second op amp, there are multiple ways of solving it. We could have used superposition theorem also, but here we have gone for the nodal analysis method. And so with the nodal analysis method, note that because the op amp is an ideal one, therefore the voltage at the negative input terminal is the same as the voltage at the plus input terminal, which is due to the concept of virtual short. And therefore, if voltage here is denoted by V sub x, then the same voltage value will be represented here also. And then we also know that for some current, let's say this V0 is providing some current I1, and so the entire current will flow through this feedback resistance only. Because the op amp is an ideal one, this ideal op amp will offer infinite input resistance, and therefore it does not allow any current to enter the input terminal of the op amp, and hence by KCL we can note that I1 should be equal to I2. And the next part is simply framing the expression. So I1 can be represented as V0 minus of Vx divided by 10 kilo ohm, and we can represent I2 as Vx minus of V out divided by 10 kilo ohm. And so this is the corresponding relationship, and therefore V out is equal to 2 times Vx minus of V0, and then V0 was already derived as 2 times Vy, and therefore this is equal to 2 times Vx minus 2 times Vy, and if we take Vx minus Vy as common, as 2 as common, and therefore Vx minus Vy, that is the differential input V in, and therefore V out by V in, which is the gain of this double op amp structure, is equal to 2.